Hey guys, so as I said, welcome. Today is Wednesday. Let me share the screen here. Let's take a look at Brightspace. So for the course, click on it, go to content. And as you can see here, this is the content for the course. On last week, first week, we went over this module. So this module is now updated. There's an assignment due today, right? So there's an assignment due today, which we discussed. We have some word problems, right? And I showed you guys it was, I showed you the methodology to solve these problems. So we went over this, so hopefully you'll be able to submit it tonight, so don't forget. Then today, we are going to start looking at the software. So that's all I'm gonna do today is really, I haven't introduced the software, which basically it's going to be the Jupyter Notebook. So we'll be using that. Now, Jupyter Notebooks works on Windows easily. So what I would recommend is just go ahead and install it, or if you haven't done so already, and then we'll work through some of the problems today. So today is kind of a warm-up. You can see here I have this link called Numpy examples. Don't stress too much if you don't get everything about these Numpy examples. This is something that over time you'll get, okay? So today is more of a warm-up, if you want to think of it that way. We're just going to go through some exercises and I'll show you how it works. And if you remember, in the previous lecture last week, we basically focused on, so let me actually go to the whiteboard here. So in the last week, we focused on problems, right? Any kind of problem. We looked at image processing, speech, network security, etc. We looked at all these problems. And then I said to you, you need to come up with X and Y, which by the way, X has, specific shapes. So this is going to be N by M. This is N, this is 1, right? So we talked about this. So basically, what this means is that any kind of machine learning problem ends up being it ends up being converted into these shapes. Maybe a little bit more complex with the more advanced topics, but at the end of the day, it comes out to this. And this has basically looks like with data, 1, 1, 3, 5, 7, 5, 2, 1, 0, 1, 3, 2, 1, 0, 5.7, right? So all of and this can be bigger than that, obviously, but what I'm saying is they end up looking like this, and these end up looking like something like that usually, right? We talked about the labels and the X's. If you don't remember, just go back to the videos, you'll get it. So we're going to refer to these as whenever you have two dimensions, N by M, you're used to probably calling it like a two-dimensional array, but in the terminology that we're going to be using in machine learning, in the machine learning foundations class, we're going to call this a matrix. Like the movie The Matrix, right? So a matrix. And we're going to call this a vector. So a vector is just, a one-dimensional array, if you want to think of it that way. A matrix is a two-dimensional array. And let's say that we had data that looks like this, but we're also storing data, kind of in a cube, right? Which we could, a perfect example of a cube, when you think of data, is actually what? Video, right? Video is a very example, or even an RGB image, right? So if you have an image that is color, it's not just one grid, but it's actually three. So technically speaking, you're talking about something that is, I can't draw today, sorry. So we're talking about something that is n by m by 3, right, for an RGB by 3. So this dimension is 3 because you can store, you know, the values for the red, the values for the blue, the values for the green. So that's then also kind of a matrix, but it's a 3-dimensional matrix, right? Do you guys see that? And we could store even more data because we could store then, for instance, in a bigger dimension, if you will. And I'm not gonna draw them next to each other because it's gonna, well, I guess I can try. You see how these are sort of next to each other? You see that? So I've got 3 cubes there. So these 3 dimensions are actually in one additional dimension, right? So I'm adding a 4th. And this, for instance, would be a good way of intuitive thinking of video. Because in video, you're going to have one color image plus the next color image plus the next one. In fact, in how many frames per second do you have? You have like 30, right? 30, 24 or something at minimum. Some have 60, etc. So my point is, if we go back, we started looking at these at this terminology, matrix, vector, right? And so these are just ways. These are just ways of storing data. That's all it is. We're storing data. You know what you did basically all of last week with the problems, putting it in words and writing it in pencil. Now, you know, we understand that we are going to use these data structures. So again, if it's a one-dimensional, call it a vector, right? So it's a one-dimensional array. You guys understand that. So n by 1. It's a two-dimensional array, and I'll change colors. A two-dimensional array, n by m, right? We're going to call it a matrix. But I've also shown you that it could be 4 dimensions, right? 4 dimensions. We can call this R4, right? And then this one, 3 dimensions, just one RGB image, 3 dimensions, right? So that then also R3. Okay, so then we have all these possibilities, right? We have, you know, 3 dimensions, but we could have 4 dimensions and it's just some, I can't even draw it anymore. No real concept, but let's just go with this idea, right? Several cubes next to each other and ... Okay, so since we initially we were doing well, we were calling things by their names, vector, matrix, but after that, we just have too many options, right? We would have to have an infinity of names to cover all of these. To cover all of these, we would have to have an infinity of names. We don't really want that. And so we just have a generic term for everything else that has dimensions, including actually all of them. All right. And so we come up with one single term, and the term is called the tensor. Okay, so you'll see this name a lot around machine learning, tensor. You'll hear about something called TensorFlow, and you'll hear about other things like in PyTorch or Keras. You need to understand what tensors are and all of that. But I'm trying to explain to you, it's just a name, and what it implies really is it's a matrix, but of any dimension, right? 1D, 2D, 3D, 4D, and so on. And remember that these matrices are used to store data. That's the purpose of it. So we usually store data, but we want to do tricks with this data, right? So for instance, we're going to learn, let's say that we have this, right? And we have stuff like that. And let's say that this is really large. This is like 10,000 by 10,000. Imagine a matrix that is 10,000 by 10,000. What do you know about traversing matrices? What you know about traversing matrices is that because there's an I and a J, you want to go through every single cell and maybe print it out. So you're going to do 4i in range. And actually, this is N and this is M. So for N, 4J in range M, right? And then you're just going to, and let's call this one M. So then you just do print M, I, comma, J. Right? And that's what you know about traversing for loops. So this would allow you to traverse. This would allow you to traverse this array, right? So you would go every row, every row, every row, every row. Now, the problem with for loops is that for loops are very CPU intensive. So that's a problem. Imagine that this matrix is 1,000,000 by 1,000,000. And you have to search it over and over to perform operations. It would take a very, very long time. Okay, so that doesn't work. So this, believe it or not, it's not an option. Can't do that. Another thing is, if I go back to this idea, maybe I just want to, segment out this data here and process it and get the average of it. So the average of those values is like 1, right? So if I want to sum them, it's going to be 5 and so on. So I want to perform operations on that data. So we need to basically then know some tools. Okay. So this is just to motivate that today we're going to cover something called Numpy. Don't worry so much if as I said, if you don't understand everything, just kind of get the mechanics of it. The point of this one is just to practice a lot, to kind of learn through practice. And later on in the semester, we will selectively use some of these techniques. So at least you will know, okay, oh yeah, it's those techniques. And you just kind of have to, I'll explain the technique whenever we're doing it, and it'll be easier. So today, so my point is, today we might do 20 of these, but there's hundreds of them. Whenever we're actually implementing a specific technique, etc., we'll use 1 or 2 at most. And so it'll be easier to explain them. But the great thing about this is today is it'll give you exposure to Numpy, which is good. And then also it'll give us an opportunity to become familiar with the software. Okay, so that's really the goal for today. All right, so hopefully that made sense. So let me get this. All right, so today then, we're going to practice with this tool. Let's switch over to Brightspace. The link is here, Numpy examples. You can see matrices, vectors, and Numpy. Next week, we will start our very first machine learning algorithm, which is the KNN algorithm. So you can see sometimes I'll put some slides. I've included these files that you see here that are IPYNB. They are Jupyter notebooks. So they're files that are that. So I have 2 here. There will be an assignment. Obviously, this is last year, so I'll have to change it. And then there's some additional information, but that will be next week. For today, we're just going to do this. However, I want to point out, I've already provided a link to the script. So if you fall behind or anything like that, you can just take a look at these these are the ones that I will be covering today. Okay, so the first thing we're going to need for this is we're going to need Jupyter Notebook, right? So if you remember, I asked you last week to install the Anaconda environment. So that's this one over here. So I'll repeat. Let me just make sure. I'll repeat. The software we're using, you can install on your Windows operating system. It's very easy to install, as Windows is easy. You click on Anaconda here, and that'll take you to this environment. And these are the installers. So you'll just install the Windows version. If you have 64-bit, do that. So I already have it, so I don't need to run it. But that's it. So once you install the software, the Anaconda environment, then you should have it in your environment, and you will be able to do things. Another thing you should do is you should create a folder in your desktop for this, right? So I believe I've created. All right, so create a folder then. So create a folder for the course, okay? So just on your desktop, create ITS 365, machine learning foundations, spring 2022. Okay. So once you have that folder created, okay, let me actually now share. Okay, so now you'll have your so Jupyter, right? Jupyter notebooks are here, so just click on that. Now, please, if you have any questions, ask or stop me at any time, right? So I started the Jupyter notebook, and you can see this is the environment we are going to be using this semester. Are there any questions? No questions? Everyone's following along? Can you guys hear me?
Yeah, we can hear you.
Along.
All right, great. So seems okay. All right, so that's good. So excellent. So yeah, so you should be here at the environment for Jupyter Notebooks. Then just find the folder. So I'm going to go to desktop, and in here find so here ITS 365 ML. So click on that. All right, and you can see I'm in my ITS 365 Machine Learning Foundation Spring 2022, and I have not, I don't have anything here, right? So now I'm gonna create a file. Okay, so I'm just gonna click New, Python 3, and there we are. So now I have a simple Jupyter notebook. I'm gonna save it. Right, so make sure you save it so you can check the folder. So just go to your folder there, and you should have a file with an extension IPYNB. Make sure you give it a name. So let's go to File, Save As, and then just give it a name. So in this one, just call it Numpy examples. Okay, that's a Numpy examples. Call it that. Save it. Okay, make sure you save it. right? And then when you check the folder again, you will have your NumPy examples in there. Just make sure you don't lose it, okay? All right, so if we want to, I will also sometimes save it as a .py extension. So for that, I'm just going to click on File. And then there's an option, Download As, and then you just set Python. I like to do this because I post the scripts on GitHub, and it's just convenient for me to have that as well. All right. Okay, so now the first thing we're going to do, so today we don't need that much software. And for the whole semester, actually, because this is a foundations course, I'm going to try to do everything from scratch as much as possible, just to give you the basic principles of, although when we get to deep learning is it's not possible to write that from scratch. So we're just going to use the very popular TensorFlow and Keras module. And so then we'll have to install something. So again, so the way that it works is when you open Jupyter, you're going to have a new thing. So look here, right? So if you're here, you go to New, this one over here, New, and then Python 3. And then just make sure once you create it that you use this menu to save as and change the name, save it in your folder. Does that make sense? Did I answer your question? Okay. All right, so now the first thing I'm gonna do is we need one library, right? We're definitely gonna need one library, which is called NumPy. So the way that it works is that I'm gonna say import NumPy as NP, okay? So that's basically the first approach. So you want to try this. So if once you type this, click run, and you should get basically no errors. So please go, this is important, guys. So can you please try that and let me know if you get errors? Are you able to get it to work? All right, so good. So once you do this, then you have NumPy. Now, if you needed to install something, if you needed to install some software, it's going to be the basic approach that you may have seen before, like something called pip install, etc. You just have to go. So I'm going to share. You just have to go to the start and then look for. You have to look for. Yeah, so click on Anaconda here, and then the Anaconda prompt. So when you click on the Anaconda prompt, then it'll open a terminal like this one. It'll open a terminal like this one, and then here you can install software. So for instance, then here you would probably try something like pip install NumPy, for instance, if you need it, if you didn't have it. Okay, so that's basically the pipeline that we would follow. But we don't need the prompt right now, so I'm just gonna close this. And now that we're here, now we're ready. Okay, so this will be our environment pretty much all semester, okay? Jupyter notebooks are pretty convenient, they're pretty standard for a machine learning foundations course. So we're just gonna take that approach. And actually for more advanced things as well, okay? So as I said initially, when I was doing the motivation, basically we have data, right? And if we have data, we need to be able to represent and hold that data. But we don't we don't just have variables like a equal 3, right? Because now usually we're going to have a lot of rows that represent the sample. So we have, you know, a sample of a car, right? So Ford. So then remember, we're going to represent its features as, it runs at, I don't know, 150 miles an hour, and it has like 19 miles to the gallon, and it's got 19-inch wheels, and I don't know, I'm making things up here, and something else. It'll do 5,000 miles before a service, something like that, right? It's hybrid, so it's a lot. And then that was just Ford, and then we have like Toyota, and then all these other ones, and then Toyota will have its own values, right? And so really now we have all this data that needs to be represented. So we need to know how to do that. All right, so we're going to get started then. So now I hopefully understand why we're doing this. So now I'm just going to do it. So notice that I did import NumPy as an NP, so that whenever I want to reference NumPy, I just do it through the word NP. It just makes it shorter, so the code is shorter and not as long. So I'm going to create a variable, and I'm going to take a list, let's say. So pretty much everything in Python is a list, as you know. And so I have a list right now of Python values. This is native Python. So 452 6, 8, right? So I have basically here I have my list of Python values. Okay, so let me also switch. All right, so you should be seeing, I think, right? Oh, yeah. Okay, so I have a list here of the values, but the list, the native Python list is not very efficient. It's efficient. I don't want you to think it's not, but it's just not efficient enough or fast enough for what we need, for the machine learning things that we need to do, because in machine learning, we usually are using a lot of data. So then we need to represent things more efficiently so that we can perform more efficient operations, right? From a point of view of, like, there's something called linear algebra, right? So there's actually a whole theory in mathematics about how to deal with those things that I was describing before, vectors, matrices, tensors, etc. There's a whole theory, there's books and courses on it. And so the idea is to be able to efficiently apply those techniques to process your data more efficiently, to gain insights. So mathematicians have figured out that they can apply certain equations or techniques or whatever, algorithms, and they can arrive at insights from the data really quickly, right? And that's really what this library is about being able to perform those tasks. So now, before we can actually efficiently process this data in this list, we will need to convert it. So now we're going to convert it into a NumPy array, okay? So remember, it's NumPy and then NumPy. This is a list or an array. So, but now we convert it into a NumPy array. So we do np.array like that. And so np.array will take in a_list, just like that. Okay. Now, if I want to view then the array, the new one, I can do, so let's do print, and I'm going to do first a list, which is the array, and then I'm going to do a, which is the NumPy array. Okay. So I'm going to run this. I'm going to save it and run. And you can see here, and you can see that they look almost the same, but there's a slight difference, right? This one has the commas, which kind of implies it is a Python list. This one does not have the commas, and this is the notation that NumPy basically uses. So this is now a NumPy array, which means that there's, whereas this may have like 10 functions that you can use on this, this has, I don't want to exaggerate, but hundreds of functions that you can apply to that data. So it just has a lot more power. Does this make sense, guys? Any questions?
It makes sense.
Perfect. All right, great. So, and that's what we're doing today. Like I said, so today, you know, we're just kind of getting into Jupyter. Our pipeline all semester will be like this. You know, I'll write a little code, we'll have some data, and we'll run it. And then, as with everything, right? So if you guys, you know, do karate or dance or play the violin, whatever it is, right? You need to determine how good you are at karate or how good you are at the violin or the other thing I said, I forgot. So the point is you need a way of measuring performance, right? You need to, you know, so in the violin, it's kind of subjective because it's the ear for us, normal people, but for a professional violinist or a, you know, conductor or whatever, they will have other measurements, more stringent maybe. And so the idea is, you know, everything that we're going to do all semester, all of our algorithms that we implement on data, we will need to measure them as well. So we'll talk about that actually very soon, probably next week. I'll introduce this whole concept of performance as well. But basically our pipeline then will involve three things usually. Getting the data, right? Getting the data from wherever and converting it just like you did in your homework, right? You had a problem and you had to think about the data and then you had to arrive at X and Y. That's the first part of everything that we're going to do this semester is we're going to think, okay, my data, how do I deal with it? NumPy, as you can see, will be very helpful for that, for this course. In other advanced libraries like PyTorch, TensorFlow, JAX, which are much more advanced, they still do the same thing. It's funny how all they do is they copy everything that's in NumPy to their own libraries. So I almost wish that NumPy was it. And hopefully someday NumPy will be its own thing that'll have all that support. But basically, you know, that's the idea. They all have this because this is essential for data manipulation. After that, there's the algorithm, right? Whatever the algorithm is that we're implementing based on the problem, that's machine learning. So you have some data, then the machine learning algorithm repetitively in a loop, right? Has to look at the data, has to measure some kind of what is called a loss function, some kind of a, you know, how am I doing, right? You know, it's trying to do an optimization, right? And then finally, once it finishes, you know, it has to finish at some point. It'll have some stopping criteria. When it finishes, you have to measure, okay, how well did it actually do? So usually you'll have maybe a held out data set that the algorithm never saw, right? Like in a competition, you would practice your you know, your cooking skills, and then you go to this cooking and tournament, and then they're gonna tell you, okay, here it is, cook this, and here are the ingredients. So you didn't know what they were gonna ask you to do. So that's kind of the same idea. So you leave a data set separate that the algorithm never trained on, and then when the model is applied to that data set, you already know, you know, these are the right answers, and these are the answers that the model says. And so now you compare the two, and that's an easy way of measuring performance. Okay, so that's really the pipeline for us all semester. Okay, so but today then we're just focusing on the first part, which is dealing with the data, and we're going to play with NumPy. So we did this exercise. Let's do another one. Obviously, with these exercises, I will not be able to get through all of them today. So your homework is going to be pretty simple. You're going to just finish them. Okay, so what I mean by that is if I go here, nope. So before I forget, because I don't want to forget. right, so on Brightspace, let's go back to Brightspace before we continue. So today, so actually, I'm just gonna do this because today is Wednesday. So you guys should be seeing Brightspace, right? So this link points to my GitHub where I have all of the Numpy exercises. Okay, I have all the Numpy exercises. There's a lot of them, I admit, but at the same time, they work. All you have to do is, I would suggest typing them up, but that may take a long time. So it's entirely up to you. I type everything. So I type everything at least once because I may miss something. But you could copy, paste them, and run them, and they will run. My point is, I will not be able to get through all of these today, and we really only have today for this. So what we will do today is I will get through as many as I can, and then you guys will just finish the rest, okay? But your homework assignment is basically this. In your Jupyter notebook, you have to run these exercises just to practice as a warm-up, and then I will write maybe 2 or 3 problems that would require you to use these, and they'll be easy, so don't worry, they're not going to be very hard, but 2 or 3 problems that would require you to use these techniques, right, to solve it. Does that make sense, guys?
Yeah.
Yep. All right, good. So before I forget, then let me just create the assignment. So I'm going to do table of contents here and just matrices and vectors, right? So I'm going to create the assignment.
Are you gonna want us to also submit the file or just screenshots of the code working?
Just the screenshots, because I already have the code, right? So you're just, so it's really an exercise that you should do as a warm-up yourself, right? Just to get into, my goal, as I said, is for you to start getting into Jupyter notebooks through this, and also to see everything that you can do with NumPy. Okay, so yeah, so just submit a report with screenshots, but have screenshots of the code and of the code running. And then, of course, if I'm going to give you 2 or 3 problems, those you have to give me your code solution and evidence that it runs. As I said, they will be easy, and but you have to write some code that runs. Okay, so obviously, no need to type, because I do think it would take a very long time to type them all up. You can just copy and paste them, but at least read them, right? Read them, and read them a little, get a feel for them, and then get the output. Okay. So let me just homework NumPy examples. Date. So this will be due, today's the 19th, so it'll be due on the 26th by 10 p.m. And then it'll stay open until Saturday. So you have a soft deadline and a hard deadline there. After that, the Dropbox will close. Okay, so after Saturday, so make sure you submit before. You don't lose points if you submit late. If you don't submit on Wednesday, you can submit on Saturday, and that's fine. But it's just a way of kind of like force, I don't know. It's something I always do. I don't know that it works actually, but I've always done it. All right. So just complete all the attached NumPy examples from the link. Okay, so that should be clear enough. And then I will provide 2 or 3 so complete the attached NumPy examples from the link. And then, like I said, I will add here 2 or 3 more, but I have to think about them. So by the end of today, I will post them. Is this clear enough on what you guys have to do?
Yeah, I understand.
Okay, great. So submit a report with screenshots of code and results from running the code, okay? So make sure you do that. Please remember, always submit to me a report. No need to zip your files. If you do want to send me your files, zip them, but put the report outside of the zip folder, because then I don't have to download the zip file, okay? I can just look at it in Brightspace. And if something is not clear in I will go to your zip file. But if you do everything very clearly in your report, I don't have to do that, okay? All right, so this assignment has been created. Okay, great. So it should be a nice little fun one, just to practice. And I promise you, if you literally, like, you might just for the homework, copy and paste them, but if you literally like type them all up over a couple of weeks, you'll get more out of it. And I firmly believe, because all semester we use Numpy for a lot of algorithms, that practicing these exercises will be very helpful to understanding the things that I'm doing later on, okay? So I'm a believer in that. Now, this is a lot, actually. I took a lot of these examples from a book, from a whole book, and it's a condensed set of problems from a book. And so I do think it's pretty good in coverage, all right? So hopefully it should give you a lot. There's some advanced topics in there like broadcasting that you will see later in those links that's actually tough. So don't worry if you don't get that one right away. I mean, I myself, I teach this class all the time, and broadcasting is a concept that every now and then I kind of have to like, oh wait, how does that work? And usually I have to look at an example. But what's important is knowing with some of these techniques is knowing, okay, to recognize I have this problem. This is a problem where broadcasting works. And then you have to spend a little bit of time understanding the problem, looking at examples of how broadcasting works, and then boom, you can create your solution. Do you guys see that? So I want you to understand that, okay? It's important in machine learning not to get overwhelmed, because it takes a very long time of things being a little bit repetitive to really get what you're doing, okay? So don't worry. But certainly this will be a good warm-up. All right, so let's go ahead then and switch over to the Jupyter Notebook again. And I'm just gonna continue, no, here. All right, so I did that exercise. So the way that Jupyter Notebook works is this is saved, as you know. Now I can just do more down here, right? And so I'm gonna do another one. I'm gonna reuse the same variable, and I'm gonna say, A equal NP dot array. Okay, and then we have square brackets here. And now I'm going to do 1, 2, 3. Or sorry, 1. We do 1, 3. I want to be consistent. 1, 3, 2, 5, right? It's just a list. Notice that now this time I didn't have to create the list separately. I'm just plugging it in there directly. That kind of just makes things easier for me. All right, give me a sec. Let me grab some coffee. All right, so this one is similar to the other one, but now the specific thing I'm going to do here is I'm also going to specify a data type. Data type. So I'm going to do float 32. Now you guys know about data types in programming. You also know that in Python, you're not supposed to or not required to declare data types, and that's true. But whenever you have in machine learning because you have a lot of data and the data is going to be, you need precision, you need to conserve space, etc. Now you once again go back to having data types, okay? So in this case, I'm doing a float 32. This is important because it defines the size that you're saving your data. When you have 1 million records, it makes a difference, okay? So now that but basically all I did is the same thing. I took the list, converted it into NumPy array of float 32 type. Now I'm gonna go ahead and print it, and I'm gonna say print A. You see that? And now I'm gonna run it. And if you notice, it's like this one over here, but the difference is you have those dots. And that's just the way that NumPy works. NumPy doesn't say 1.0, it just shows 1 point something, right? And that's again to conserve, because the zeros will be wasting a lot of space. And these are gonna be large things that we're gonna be dealing with. Does this make sense? Any questions? All right, so let's try another one. This is a list of lists in Python, so list. Okay, so this is a list of lists. And so now I'm gonna create in here a list that contains other smaller lists. So 1, 2, 3, and then comma, and then, 4, 4, 5, and then comma, and then notice this one is 6, 2. It does not have the same dimensions as the other 3, right? So if you wanted to create a matrix out of this, you're going to have a bit of a problem, right? But let's see what NumPy does with this one. So remember, a matrix needs to have some consistency in the dimensions because there's only 2 dimensions, n by m, for instance, okay? So let's take a look here. I'm going to do B equal np dot array list of lists. Okay. And so now we're going to print B. Print B. Run it. Notice what happens. This NumPy had a hard time creating this as a matrix. So it created basically a NumPy array of objects, where the objects are lists, because they didn't have the right dimensions. We would have to specify a function like fix the dimensions, etc., so that this was better. Because notice this is 1, 2, 3, that's 3. This is 4, 4, 5, that's 3. 6, 2 is only 2. So there's a problem. So now let's see what it does if we give it another example, but where the dimensions are correct. So we're going to do list of lists, and we're going to create one over here, comma, right? And then in here we have our Python list, 1, 2, 3. I have another one, 4, 4, 5. And then I have one 6, 2, 11. All right, so I have there, this has the right set of dimensions. So now I'm going to create a NumPy array, np array, right? And I'm going to say list of lists, like that, right? And then now I'm going to print out B. And when I hit run, you can see this time it was able to create the matrix because it had the correct set of dimensions. This is, in terms of NumPy, this is a matrix. This is no longer a list. This is a NumPy array So you can think of it as 3 by 3, okay? And so now you have a new set of operations that you can apply to it. Okay? Questions?
I do have a question real quick. So you made 2 lists of lists, and they look very similar to me. Do we need both of them to create the matrix, I assume?
Which one are you talking about? 4 or 5 here?
5. Does 5 rely on 4 at all?
So what's your question here?
Does 5 rely on the values of 4 at all?
No, they're totally independent.
Okay, awesome. Thank you. That's what I thought.
Yeah, so everything I'm doing is like a standalone thing.
I guess like each individual inner per se is each number is its own note file. Almost.
Yes, everything is separate. So this was one thing. This is a totally different thing. Although these are similar, I was just showing that when you don't have the right set of dimensions, it's not able to create the matrix. You see, so it wasn't able here because the last one is 6, 2. It's missing a number.
It's missing a third. Okay, I get it.
A third, yes.
Awesome. Thank you.
Without that, you're not able to, because you would have had for this one here, you would have had 1, 2, 3, 4, 4, 5, 6, 2, and it's cut off.
You can't do that. Gotcha.
Yeah. So you'd have to tell it to do something, but I didn't, so it didn't know what to do. When it's got the dimensions there, it just automatically does it by default.
Oh, that's cool.
Okay? Yeah, so that's the idea. All right, so in these, we're just learning how to create these vectors and matrices. So now let's try another one. So I'm going to do B equal NP dot zeros. And this is just a way that I can create a NumPy array that now has a certain set of values in it. Why is this important? This is important because we're going to be learning basically in machine learning kind of works like this. And if I wanted to like, in like very simple terms, right, tell you how machine learning works, it kind of works like this. I have some data, X, and I have some labels, Y. So I give it this data. Let's say I'm just going to draw it as little circles. These are the features, right? So this is my X. And then I have over here, a classification problem. I want to say it's, happy or sad, right? Given that I have some data about your face, right? So are you happy or sad? And then here I have information about your face. So usually what happens is I have the X and the Y, right? And then the model is going to learn to predict Y hat, basically something similar to the Y, right? But here I know this data with the model, I'm going to predict that data, right? But to be able to predict, you have to build something in between. You have to have like a little black box in between, okay? And so that's what machine learning is figuring out what that little box in there should be. So I'm just going to draw an example, a very simple example of what it could be. So if I draw 2 lines, 2 blocks in here, and I put circles in them, and the number can vary, right? So this is just an example. All I have to do is decide, it's basically like a road, right? So whenever I have a certain set of values, right, in a certain way, those values do that. It's like they take a specific road. Do you see that? And so the way that you account for that is by putting numbers. So all of these are connected. So there's other lines that are connected. So for instance, if I do, that one is connected. The problem is that, not the problem, it's connected, but the logic is it's connected, but the value is 0. Whereas this one is 0.5. So what happens? in essence, when the value here is 0, it means it's not there. It's unimportant. Whereas the 0.5 value is actually means that the road stays there. Another way of looking at it is if it's almost 0.0001, it's not going to win against this one that is much higher. You see that? So that's basically what a machine learning algorithm is just this idea that from the inputs to the outputs, you have to have like a mechanism that connects them and tells you whenever I see these values, it's like I'm gonna it's like a circuit. So it's a good example. A good example is a circuit, right? So if you turn a switch on and then a light comes on, right? So it's basically like this. If I do this, right? Let's say I have 4 switches in my house and I play with them. I do that, all the connections will light up this one, right? For this combination. If I have another set of switches and I just turn them on like this, what might happen is, if I use another color, is that these are connected like that and could possibly like that. And they light up that circuit. Do you see that? Does this analogy make sense? So it's almost like electricity in a sense that if you have one set of switches, it'll light up the red. If you have another set of switches, it'll light up the green. And so then basically that correlates to happy or sad. So that's kind of what this is doing. So what's important here is we have another element, the values on these lines, right? And that's usually called the weights vector. So for instance, here, I know that there's a 0.5 and a 0.001, right? So the way that this works is you have the inputs on one side, x1, x2, and then the weights on the other one, w1, w2, like that. Or sorry, not the weights, these neurons on the other end. These ones, these neurons, H2, H3, H4. So these are H1, H2, H3, H4. And now you're able to find the values corresponding to these. So for instance, the value between x1 and h1 is 0.5. The value between this one, this is x3, so it would be this one, x3, and h2, right? So that will be, this value here is 0.001. All right, so that matrix that you're trying to learn is the whole game. That's it. Like that's where the big bucks are, right? There's actually a business now of our business model where people want to buy your weights. Sounds crazy, or funny, but actually because when you have a very large model, right? You have a very large model. First of all, if you're not Google, you don't have a lot of data, right? You don't have the data that Google has. So Google is able to build an algorithm, use their massive amounts of data. They have a lot of resources, right? And so they have supercomputers. They can also have a lot of smart people, and they can run an algorithm for 38 days straight, right? They don't care. So at the end of the day, what's happening is they're feeding it lots of data with possibly some labels. So they've got the X and the Y, right? So they got the X and the Y. And what they want is this W, another matrix called the weights. Do you guys see that? Do you understand that? So a model in machine learning now, it's got the X's, it's got the Y's, but after training, what you're looking for is that weights matrix, like the one I showed here, this one. You see that? Initially, that weights matrix will be what? Lots of things. It could be zeros, it could be random, it could be a normal distribution, something, because the values are not correct. Initially, the model doesn't know these values. So initially, the model is like this, a whole bunch of question marks. but you have to initialize it to something. All right. And so that's what I'm going to be doing now is I'm going to start initializing a whole bunch of vectors or matrices that, and the reason is that they could be the weights that you're looking for. Once you're Google and you've trained a model and you know the weights, that becomes a very valuable commodity, because people that don't have the computing power or the data could still use those weights on their own model, some of them at least. All right, so that's usually called transfer learning, but that's another concept. But this, what I want to point out is that why we're going to initialize these matrices to values initially is because they need to be something. And then as we train, the values are going to become populated. Okay. So anyway, let's go back then to the code over here. So I'm going to do NP zeros. So this is going to initialize to zeros. I'm going to say that I want 10. I'm not really specifying dimensions here. The data type, I'm going to say that I want it to be integer. Int. Okay. So now I have print B like that. And so I'm going to run it. And I've got there my matrix initialized to 10 values, or sorry, my vector basically initialized to 10 values, all of which are 0. Okay. So that's the basic idea here. Are there any questions so far, guys? Okay. No questions? All right, so let's just keep going then. So let's do the next one. Now we're going to do B equal okay, so B equal NP dot ones so 4,6 D type will be float. Notice this one's a little bit different, a more generic float. Notice this has this 4,6. That means the dimensions of the matrix. So now print B. If I run it, oops, missing a comma. And there it is. Notice that they're float. They're all ones. And this is 4 by 6. So it's got 4 rows and 6 columns. So basically you could think of it as it's got 4 samples and each sample has 6 features. Remember the terminology that we all need to speak, right? We all need to have the same lingo, okay, so that we know what we're talking about. All right, so let's do another one. So B equal NP dot full. And we're gonna say that this one is 3 by 3, 3,3, and the value will be 42, the initial value. We print this will be B. All right, so now we can run this one, and you can see it's initialized to all 42. Pretty easy. Let's create another. Let's try another one. So B. This is gonna be numpy dot a range. Yeah, so remember, this is a vector, this is a matrix, okay? So we're creating, I've only initially called them arrays because you're familiar with that terminology, but we should switch from the arrays terminology to the vectors and matrices terminology, okay? All right, so let's try another one. A range allows us to initialize a range of values. So we can say, for instance, from 1, 30, step 3, okay? By the way, I should say, although this is for machine learning for the class, Numpy can be used in other fields. So there's no reason why whenever you're doing something, a problem in another course, that you can't just apply these techniques, right? I mean, it's totally doable. All right, so I have a range here. The step is going to be 3. So now if I print, I'm going to do print B here. And so I'm going to save it and run it. And you can see I created a sequence, a NumPy array that starts at 1, then 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, and so on, all the way to 28, because 30 is the limit. Let's try another one. Line spacing, these are going to be values between 0 and 1. So I'm going to do B numpy dot linear space, line space, and it's going to go from 0, 1, and there's 20 of them. All right, so the values that are created are in this range. So you'll see what I mean in a second. If I do print B, right, and you can see the values there, right? So it created about 20 of them, 20, and they're all in that particular range. Now, as I said, going back to the analogy of machine learning, we said that we wanted to learn these weights, right? 0.5, 0.001. We are going to initialize our weights matrix to something. Now, initializing to zeros is not always a good idea, because then you're kind of always starting at the same point if you think of it. The best analogy that I can give you for this is something like this. So let's say this analogy actually applies really well to the math behind machine learning, but it's a good analogy in any case. Let's say that your goal is to find the optimal set of weights, right? So really the optimal set of weights, you could think of it as like a treasure, right? So the optimal set of weights is hidden here, right? That's, that's the optimal set of weights. You're looking for that. And so what happens is, this is at the lowest point because it's usually an optimization of cost. So you're minimizing cost in a way. You have this idea that you want to minimize the cost. And so the weights are there, right? The optimal set of weights is right there. The problem is that there are other sets of weights here. There are other sets of weights. And you are a person literally searching for these, right? So you're a person searching for these, and you're just going to be everywhere, right? Looking for things. And all you can do in this world is either go left or go right. You're walking across these lines. So the problem is there's another set of weights here, more weights. And because this is an algorithm that does things repetitively, what can happen is this person could just get stuck in here. Just, going back and forth within this, eventually the algorithm will end and it just found this set. It never got to this one. Do you guys see that? And the problem for that is that your initialization values, because they were all 0, they always kind of put you here. That's why it's good to kind of, have a random set of numbers, etc., because it gives you the opportunity to explore other ones. If you think about this one, although not the optimal, it's a little bit lower than the other one. Do you see that? guys. And then hopefully with a good set of weights, you would end up here and going in this direction. If you do that with enough iterations, you will get to the optimal set of weights. And so that is a good analogy, I would say, of how this works. It's a search, basically. It's a search type of an algorithm efficiently across a mountain range, which is a function. Because, you know, you guys know, for instance, that, I mean, this is something you learn in geometry. You know, what's the function? What is this? Let me draw this for you. What's that? What is this usually called? If I want to plot those values, what is that usually called? You don't remember? So this is the sine function, right? So this is the sine function or the sine wave. So given some values, it kind of predicts this behavior, little curve there. So usually what you end up, so the same thing applies here. We have some other function, just a much more complex function than the sine wave. So the sine wave is just, you know, this shape. We have other functions that could represent this mountain range, and then over this function, you're searching for these weights. Okay, so that's a good analogy, I would say, of you know, how this basically should work. All right, anyway, so let's go back to our code. So that's why it's probably better to initialize randomly, if that makes sense. So then I'm gonna do numpy dot random dot random, and in here I'm going to create a matrix of size 4, 4. Okay, and I'm going to print it out. So I'm going to do print B. And now I can run it, and there it is. Notice that this is a 4x4, 4 rows. So 4 by 4. Let's say we're thinking about weights here. So this would be, you know, 4 inputs and then 4 neurons in the next layer. But the values are now randomized, which gives you more opportunity to kind of fall in different places of that function I showed you, and then hopefully find the optimal set of weights. Because the function itself is used to find that set of weights. That's kind of the intuition. But this idea of the mountain range and everything, we'll come back to it a little bit more later in the semester. I'm just trying to tie these now to, you know. Now we can do another one. Instead of random, it can actually be something from a normal distribution. So it can be np.random.normal. And what that implies is that now you have some parameters that define a normal distribution. So something you probably learned in your statistics course. This is where, you know, that's why, you know, in the concentration actually of the 5 courses, one of them is that statistics course that you take. And if you're CIT students, you have to take it anyway. So it's kind of covered. But basically there, I'm sure you learn about the normal distribution, et cetera. So that's what we're doing here. So 4, 4, and then I'm going to print this one out. So print B. Okay, so now I'm going to run this one. And so you can see the values there. If you look at them, they're basically, all those values follow a normal distribution that is centered around 0 with a standard deviation of 1. So what that means is, if we look at this one over here, we've got a normal distribution, right? Which means centered around 0 with a standard deviation of 1. All right, so whenever you pick values from this, then randomly, they're gonna tend to be, you know, around this. So some of them are gonna be a little less than 0, others are gonna be a little bit more than 0, and so on. But that provides, distributions provide an additional piece of knowledge for the model. So it certainly would be helpful if you know what that is for your problem. All right, so that's another example. Now there's one matrix called the identity matrix. So let's try that one out. There's a few of these. So NP dot I for identity matrix. And this is a square matrix, which means both N and M are equal. So then we're going to say, for instance, 5. And then I'm going to do print. And then just print out B. So then I'm going to run this one. And there you go. The identity matrix, if you notice, everything is a 0 except the values on the diagonal. And this is useful because it's a way of performing a multiplication later on. So very much like when we multiply 5 times 1 equals 5, this is similar, but for matrices. So if we want to get a matrix and kind of get something out of it, we perform these types of operations. But this is just an example of how to create it easily. Okay, let's look at some additional examples here. So now I'm going to create 3 matrices. So I'm going to create B1 np.random .randint 20, comma, and then size equals 6. And then I have another one, B2 np.random.randint. This one is so this is the maximum value, 20. So you're generating numbers, you know, up to 20, basically, randomly. And then here, the size, so 20, comma, and then the size here, this is going to be a matrix. So I'm going to do dimensions 3, 4. And then I'm going to do B3 np.random.randint 20, comma, size equal, and then this one is going to be actually a three dimensions now. So a cube in a sense. So 2, 4, 6. These are a little bit harder to visualize, but we'll see this in a sec. So I'm going to do print B1, print B2, print B3. All right, so we're going to print out these and just get a feel for what they look like. All right, and you can see them there. You have the first one, it's this one. Then you have the second one, which is this one, the 3 by 4. And then you have the third one, which is that one, like that. That's the third matrix, B3. So let's actually comment out these two. And let's just run this. I'm going to do run. And you can see that all I'm doing is I'm showing B3. because it is of dimension 2 by 4 by 6, the way that you can interpret this, I usually would think of it as a list of matrices, for instance. But the first thing is this, right? And then that first thing contains two things, which are this one and this one. So that's the two. Then for each one, you've got 4. So that's 13, 0, 10, 14. That's the 4. Or down here, 14, 19, 12, 12. That's the 4. And then finally, you've got the 6th dimension, which would be along that. So like that. And that's basically a 3-dimensional matrix, a cube basically, of data, okay? So if you had an RGB image, for instance, the image would be, each image would be 3 by 4, the picture, but then you would have the R, the G, and then we would need a third one, you know, the B, right? So if we wanted, let's say that I wanted to create that one, just gonna do 3, 4 by 6, run it. This is an RGB image. Does that make sense? Any questions? What's great about representing the image like this is that because it's in Numpy, we have a lot of operations that we can perform directly on this very efficiently, fast and easy, instead of doing a lot of very difficult coding. So we just have to get used to this environment initially, but it should be pretty helpful. All right, so now it's very useful a lot of the time whenever you have NumPy arrays to look at the dimensions. So here, for instance, I'm gonna do, let's say print, and I'm gonna do B2 dimensions, right? So then that's gonna be B2 dot dim for dimension. But I also wanna print out the shape of B3. So I'm gonna say B3 shape, comma, B3 dot shape. All right, I can also do the size. So let's do B2 size, print B2 size. So that's going to be B2 dot size. And finally, the data type is something else that you can print. So I can do print, and I can do data type of B3. And then we're going to say B3 dot D type, like that. All right, so if we run this, you can see here, oh, there's an error. It should be ndim here, sorry, ndim. Okay, so if we run that, it should work now. And there it is. So the dimensions of B2 are 2, which is true because there's the 3 and the 4. It's a matrix. The shape of B3 is 3 by 4 by 6, which is true because that's how we defined it. The size of B2 is 12. So the size of B2 is 12 because 3 times 4 is 12, right? So if we print back B2, there it is. And the size of it is 12 because there's 3 rows and 4 columns. So 3 times 4 is 12. The data type of B3 is int 32. Okay, so these are some useful things that we can do with matrices, you know, to kind of initialize. Any questions? All right, so now the next thing we want to take a look at is something called indexing, which basically means now you have a Numpy array, you have a matrix, a vector, a tensor, and you want to extract something from it, right? So you want to extract some values from it. So this is going to be called indexing. So I'm just going to add this indexing, and I'm going to say A equal NP dot array, NP dot array, and then I'm going to do 1, 2, 3. I'm sorry. 3, 2, 5, comma, and then D type equal float 32. All right, so now I have this, and I'm gonna do print A, first of all. So let's do that. All right, so we've got a vector of 4 values. Now this is called slicing, or indexing too. But basically we're gonna start taking data out of these vectors and matrices, like intentionally, but just a piece of it. So the simplest thing is just to take print the first element, right? So this will be the first element. So I'm going to say A0, right? If I run that, it'll give me 1. So I grab the first element. If I want to grab the second element, or actually the third element, I'm going to do 2. So that should give me 2, the number 2. And there it is. I got 2. Now, what about if I want the last value? Well, the last value would be 0, 1, 2, 3. But if it's a variable matrix, you probably wouldn't know that. But you might know, unless you do like a length and everything. But a quick way of doing and getting the last element. So let me do this. I'm going to print. I'm going to say last element, which would be 5 in this case, right? Last element, which would be 5 in this case. All I have to do is I print A, comma, or A, and in here I do -1. Okay, by doing -1, I will get the last element, which should be 5. There it is. Last element is 5. If I want to get the one before that, so the second to last, or first to last. So I'm going to do V. Oops, didn't copy that. All right, there we go. So let's call this one before last, actually. Before last element. All we have to do is -2. So that would give us this one, the number 2. So if I run that, and there it is, number 2. Okay, so this is the approach that we can take to obtain our values, okay, our values. Now, if we have a 2-dimensional array, we have even more options. So A equal NP dot indexing. And then I'm going to move this down here. And so we're going to say, notice that I'm going to create this That's a matrix, but it's going to be made up of other ones. So I can quickly do 1, 2, 3, 4, and then add a comma here. And now I'm going to do another line, 5, 6, 7, 8. And then I'm going to do one last one, 9, 10, 11, 12. Right. So this will create basically a 3x4 matrix. So I can just print that one out. Numpy array. So I'm going to do A. If I do run, let's see, there's an error. What's the error? Oh, I'm sorry. I wrote indexing. Creating a numpy array. Okay. Try again. And there we go. So I took this, I just kind of hard coded it like this, a list of lists, and it converted it into my matrix, which looks nicer too. So now if I want to extract values from this, let's say that I want to extract the first element, right? So I'm going to say print, and I'm going to say A 0, 0. So that's the first element. And then I want the last element in the matrix. Last element. So I can say A 2 minus 1. Right? So this should give me the last element. So I'm going to try this. And there you have 1 is the first one. Got it. 12 is the last one as well. So I've got both of these in there. So now let's try a little bit of slicing. So slicing is a slightly more complex thing, but also very interesting. So let's create a simple vector np.arange of size 15. Okay, and we're going to print this one out. X. So you can see that there. I have my vector there. Now I want to slice. So let's say that I want to print out the first 4 elements. So print first 4 elements, right? So then I need to grab from X and I need to slice this out. So the way that you can do it is you use a colon to indicate ranges. All right, so in this case, I could say from 0 to 4, right, to grab the first 4 elements, but also you don't have to specify an index if you're starting at the beginning, so then you can just leave it blank. So just leaving it blank is the same. Now, if you wanted a specific starting point like 2, then you can specify it. But if you're just starting at the beginning, you can just leave it blank. So if we do this, it should give us the first 4 elements. So now let's run it. And you can see there, the first 4 elements are in fact 0, 1, 2, and 3. Okay? Now let's say that I want all the values after the 3rd element, right? So then I could say print, I can say all after 3, all after 3. So that's going to be then X 3 colon. So that, again, I could say, because we have 15, so I could say from 3 to 15, or 13, but since I know I'm going to the end, I can just leave it blank like that. So now if I run this one, you can see I've got all the values starting at 3. Remember, this 3 here is index, not the value itself. I know that may be confusing, but we're talking about the index. So it goes all the way to the last one, okay? And this is called slicing, which allows us to take things out like that. So there, we can also do a step size to say, grab all the elements. Yeah, it starts at 0, usually. Another thing we could do is we can grab, let's say that I wanted to grab all the even values. I want to grab all even, right? So how do I do that? So I'm going to do print even. And to do that, I'm going to grab X. And I would say from beginning to end. So grab, you know, this just means from the starting point to the ending point. But I need to specify a step size. So then I add another colon and I say 2. So that would imply that it's going to, because it starts at 0 and the step is 2, it's 0, 2, 4, 6, 8. So it's only going to give me the even values. Oh, yeah. So, comma, like that. You guys see that? So now if I run this one, there it is. It returned only even numbers. Notice 0, 2, 4, 6, 8. If I wanted to do uneven, I can do the same, but just shift it by starting at 1, right? Starting at 1. So now I do that, and notice it gave me uneven. So 1, 3, 5, 7, 9, 11, 13, just by doing little tricks like that. It makes it a lot easier to do. Now, if I wanted to step through the values, but in reverse, what I could do is I'm going to go from beginning to end. So I can get rid of that one. And I'm just going to say start at the end, -1. So now I do -1, boom. It reversed it. So now it's 14, 13, 12, all the way to 0. You see that? So this is called slicing. There's a lot that you can do with this, but this is just a quick intro. All right, so we are out of time for today. Again, remember the homework assignment is basically to complete these exercises. Okay, so you're going to go here to the module, and basically, I did a lot of these, but I haven't finished them, certainly. So copy paste them. There's a lot of them, I know. So just copy paste them, run them, kind of study them a little bit. And then I'll probably set up like 1 or 2 exercises. I do think going through these now, it's going to pay dividends later. There might be some in here where you need to install this additional library, matplotlib. So remember, I showed you how to do that. Just go to the conda prompt, try to install it, and you should be able to complete it. All right, so I'll stay for a couple of minutes. If you have any questions, let me stop the recording.